Hi, my name is Bill Burns. I'm the Director of Product Development and the Product Manager for TotalView. Today I'd like to give you a quick demo of the memory debugging technology inside of TotalView called MemoryScape. So let's start off with just a quick demo of how MemoryScape works, and I'll talk through the different features that it has as we go into the demo. So I'm going to run memscape or MemoryScape from the command line here. And let's take a look at Git as it does a clone operation of a local copy of the React repository. So let's load MemoryScape. Okay, the interface is a workflow-oriented interface specific around memory debugging. And to start Git, to do the clone operation, we can just click the Start button here. So Git will go through and do the clone operation. We can take a look back at our console here, and we can see that the cloning is done. And MemoryScape will stop the Git from exiting here so we can examine the usage of its usage of memory. So let's start actually just we can see how many leaks that Git has. So we'll click on the leak report here. And we can see that during this run it leaked almost 1,200 bytes of memory across almost 9,000 individual heap blocks. They all happened in file wrapper.c. and across these different function calls. I can drill down in any one of these right down to the line of code where the memory was allocated. Of course, we can't tell you where it was leaked because that's your program when it loses the pointer to that allocated block of memory. Another way of looking at memory that I like to do is just to look at the overall heap itself. So let's jump over to the heap status and look at a source report here. This is showing the full heap that existed when Git went to exit out. So it had almost 15 megabytes of memory across 14,000 individual heap blocks, and we can see all the locations of where those were allocated. Here's that wrapper.c again, and if I turn on detect leaks, I can see that in addition to the leaks that are in there, much of the other memory that is allocated is done through here as well. There's a couple different ways of looking at the heap status as well. I can look at it in a graphical way, and it'll draw out a picture of the heap showing the allocated blocks in green, deallocated blocks in gray, and clear areas in between are just memory that's unused, where often the system allocator had to byte align the next block of memory going through. I can look at my leaks here as well and see all the different regions on here. I can click on any block and examine information about the block as well. I can look at the way the operating system looks at memory as well. And here we can see the amount of text segment data, the amount of the heap itself, and also the virtual memory. So in this case here, the operating system did give about almost 350 megabytes to Git as it ran. So I would guess as Git went through the operation, it allocated a lot more memory here. All these are different pieces of information on how your application uses the heap, and it can help you get a picture of what happens during the run and help you detect problems of your application as it runs through and uses allocated memory through the heap. All this information can be stored off in a memory debugging file. So if I jump back to one of these source reports, I can exit all this data out to a memory debugging file so it can be loaded again, and I can do all the same analysis that we're doing here. I can also save all this out as HTML reports if I want to share it with colleagues as well. There's a number of other options with MemoryScape, so I can look over at the memory options itself and go to the advanced options. I can turn on guard blocks that can allow us to check for buffer overruns with MemoryScape, and it'll report a buffer overrun. I can turn on painting of memory, and we can paint allocations or deallocations of memory, and this can help provoke access to memory before it's initialized or access to memory after it's freed and you're accessing it through a stale pointer. And finally, an advanced way is hoarding memory. So when memory is freed, we don't really free it or allow it to be freed through the operating system, and this could allow your application to continue to run for a while before memory is reused and allow you to debug really hard memory problems. This has been a quick overview of TotalView's memory debugging technologies through MemoryScape. For more information about TotalView and its memory debugging features, please visit us at perforce.com. Thank you.